design patterns. Welcome to our today's speaker, Dr. Pradeep Kumar. Dr. Pradeep Kumar is an assistant professor in Anurag University, Hyderabad. Welcome, sir, in webinar. You can start with the presentation, sir.
Thank you, Mang, for my introduction. Shall I start my presentation?
Sure, sir.
Okay. So, good afternoon, guys. This here, Dr. Pradeep Kumar, and presently I'm working as assistant professor in Anurag University. So, the today topic is design patterns. So, here you can see some 4 pictures are here. You can see those 4 pictures. So, these are these people are called Gang of Fours, and these people only started the design pattern concept, and the book they have written design patterns practices. So, and all refer same patterns in order to design the softwares. So first is Eris Gamma, then Richard Ham, then Ralph Johnson, then John Wilstes. So these are the 4 persons called Gang of Fours. So we'll go with the objectives. So today objectives of today's session is know what are design patterns, then we'll know about Gang of Fours pattern, then we'll come to know how to select and use the pattern, then how to apply the pattern. And in today's topic, in today's session, I'm going to discuss what is design pattern, need of design pattern, use of design pattern, design patterns in Smalltalk and MVC, and describing design patterns, catalog of design pattern, organizing the catalog, and how to select a design pattern and how to use a design pattern. So we'll start with the first introduction of design pattern. So here, what do you mean by this pattern? Actually, these patterns are the pair of problem and solution. Okay, so here each pattern is going to describe a problem which occur again and again in our environment, and then describe its core solution to the problem in such a way it can be used million times over without ever doing it in the same way twice. So this definition of the pattern given by the Christopher Alexander. So here these patterns are going to first, it will describe the problem which are going to be occur during the designing of the software, and along with the solution will be written in such a way so that it can be used any number of times, and no need to do it from the scratch. Already solution in there, that solution can be reused. And these patterns mainly used for the object oriented programming. Okay, so here if we'll take the example of cooking. If we are going to cook anything, we can prepare same thing in many ways. Like I want to prepare something like some curry. So to prepare the same, like I want to prepare one aloo curry. So for that aloo curry, there are different recipes. So here, this recipe is nothing but patterns. So based on your recipe only, the taste is going to differ. Tests are going to differ. Okay, and how these patterns are going to be finalized. So it depends on the experience. Okay, like if you are going to play a puzzle game, first time you will take more time. Second time you will play less. You will take less time to solve that puzzle. And if you go third time, you will take very less time. And if you play same game again and again, you will take very less time. Immediately you can solve. Okay. So here also these patterns also is like with the experience of the people. These are solution came from the experience of people. So here, if you are going to solve a problem, first time it will take more time. Second time you will do some modification or you will make it somewhat good, make some changes. When you will find that solution is good, then that solution can be used for if you are going to solve similar problem any number of times. Then here design patterns are repeatable or reusable solutions to the commonly occurring problem in the certain context in the software design. So as I told you, these are the reusable solution. So any number of times then can be used the problems which are going to be occur in the software design. So here there are 4 essential elements of the pattern. First is the pattern name, then problem. Sorry, shall I on the camera? It's required to on or it's on? So there are 4 essential elements of the pattern. First is pattern name, then problem, and then solution and the consequences. So here, what do you mean by pattern name? So this pattern name is going to describe the design problem, its solution and consequences in the word or two. So in 1 word or 2 word, the pattern name is given that will describe the problem and its solution and consequences. Next is problem. So the problem describes when to apply the pattern and in which context we need to apply the pattern. In which context we need to apply the pattern. Next is solution. Here the solution is described in terms of classes and object that makes up our design, that make up the design, their relationship, and okay, so it will solution describe the like classes and object that make up design and class and object relationships, responsibility and collaboration. So this solution is not for the particular problem, and it is a generic solution and it can be used for in many different situations, but it will not give a complete implementation. Okay, it is it will not a complete, it is like a template. It is a template of the solution and template, and in that template depends on our need we can keep the information. Then consequences. So consequences tells us what is the cost and benefit of the applying the pattern. So it is related to time and space complexity, language and implementation issues, and flexibility, extensibility and portability. Then we'll go for the next thing, this need for design pattern. So if you want to design a reusable object oriented software, okay, it is a very hard process. So if we'll go with the design pattern, it will make it somewhat easy. Then experienced designer versus novice designer. So if you take the experienced designer, So they will take very less time to develop a software. If you will give same product to develop for the novice designer, so he will take much more time to develop the same software. So here, what can be done if already experienced designer derive as uh, he developed some solution that can be used by the novice designer, so that the software product will be developed in the less time. Then patterns makes object-oriented software flexible, elegant, and reusable. So if we are using the pattern that if that make our software flexible. What do you mean by flexible? Flexible means easy to use, and if we want to do any extension in the future, we can do, and it is reusable. It can be used many times. Then solve problem previously, but don't remember when and how. Okay, so here pattern, like if we'll have the patterns, we are going to keep those patterns, so we'll have the data of which problem this solution has been solved and how it has been solved. The next is use of design pattern. So it makes it easier to reuse successful design and architecture. Make it easier to reuse successful design and architecture. Okay, so if there are many already some designs or architectures are there that are successfully developed by some designer that can be reused, make it easy for the new developers to design a software. So already we are having some old designs and architecture that can be used by the new developer, that will help the new developer to develop the software. Allow to choose different design alternatives to make software reusable. So here to solve one problem, there are many solutions. Okay, so here we are having freedom to choose the best solution for our problem. Sometimes some solutions are related, but based on our requirement, we can choose one among them. Then helps in documenting and maintaining the software. Okay, so already we are having a full-fledged solution is there. So documentation and maintenance of the software is easy. So the main advantage of using the design pattern, we are going to get the design in right manner and in the faster way. Why should we use design pattern? When already there are already tested and proven solutions are there by many experienced designers. So why we should go to design a new solution? Okay, so we can save that time. And already that solutions are already tested, and by that many software has been developed by many experienced designers, so that can be reused. If you are going to find a new solution, it will take extra time, and same time it will take extra effort also, and we don't know whether that solution is correct or not. It will lead to a right product or not. So that's why we should go for. So here when we are going to use the design pattern, it assures that you are going in the right direction to develop the software. Then MVC architecture. So you can see this is the MVC architecture: model, view, controller. So here, what do you mean by here model? So model we are going to create to solve some problem, and view is for there are we are having different models to represent our this solution, and controls are there to control the all the activities. So this MVC architecture, you can see that most of the this model view MVC architectures are going to be used to solve different problem. So model is nothing but object, view is the representation of the model, and controller specify the user interface. So when this MVC architecture was not there, then we were having different model and view, and this was different objects. So now these are coupled together. So that is model view architecture. Okay. So if these are coupled together and these are tightly coupled, then what happens if we are going to make any changes in the model or model view or controller, controller, it will affect any other. Okay, so like if we want to make we are going to view the objects using subscribe notify protocol, and whenever there is some changes in the model, then it will view is going to be notified for that, and it is going to be updated by itself. And you can see this here. So here this is a model, these are the different view. If you are making changes here, 50, 30 and 20, so every view is giving same. If you are going to make the changes in the value of B and C, you are making B 20 and C 30, you will find that every views are going to be changed. So you are making changes in the object, and it is also effect on the representation. So another feature of MVC is view can be nested. Okay, so view we can nested means it can it will be one after another, and here we will have the button, and in that case we will have the composite view. So if you want to, whatever view you want to see, you can click on that view will appear. So if we'll take this small talk MVC, here 3 patterns are used: observer pattern, composite pattern, and strategy pattern. Here strategy pattern is used for controller. Okay, so we may have different type of interface. So different type of interface, for that we'll have strategy pattern. And observer pattern is like if any changes in the one object, it will make the changes in all other object. And composite pattern is used for the views. Then describing design patterns. So every design patterns are this will have the same descriptions. So here format is same for every design pattern. If we'll take first, there will be pattern name and its classification. Then what do you mean by here pattern name? Pattern name specify what the pattern is going to do. Actually, what type of problem the pattern is going to solve. And here the pattern name should be it should be related to the problem, and the classification is related to what type of pattern it is. Then intent. So here one short statement will be there that tells what the pattern does and what design issues, what pattern does and what are the design issues and problem it is going to solve. Then next is also known as, third field will be in design patterns, also known as. So here it will tell what are the other names for the design pattern. There may be one standard name will be there. Sometime pattern is known by some other names also, that will be mentioned in the also known as. section. Then motivation. So here one scenario will be given that will tell about the problem and how the design pattern, how the class and object of the object structure solve that problem. That scenario will be there in the motivation. So by that we'll come to know in which scenario the pattern need to apply. Next is applicability. So it specify in which situation the design patterns can be applied. Design pattern can be applied, and what are the examples? There will be some example for poor design that pattern has address. Okay, so poor design. What are the poor design the pattern has address that will be there in the applicability. Then structure. So this structure will be the graphical representation in the form of classes. In the form of classes in the pattern solving the notation of object-oriented modeling technique, and we also use the interaction diagram to illustrate the sequence of request and the collaboration between the object. Okay, so here basically the structure only will give the complete. This is the, we can say that this is the only the solution. This is only the solution to the problem in the form of class diagram and interaction diagram. Class diagram and interaction diagram. Next is participant. So here all the classes or objects are there in the class diagram that are going to be listed out along with their functionalities or responsibilities. Okay, along with their responsibility. Then collaboration. So collaboration will have the information about how the classes and objects are going to interact to carry out their responsibility. Okay, how those are going to interact or collaborate to carry out their responsibility. Then consequences. So consequences will tell us about the cost and benefits of using the pattern, and also tells which part of the system can be changed independently. Then implementation. So this implementation, it will tell about the techniques we should aware when we are going to implement the pattern, and also tells us if there are any language specific issues are there. Then sample code. So here some code fragment will be there that tells us about the implementation of the pattern in C, in C++ or Java. Okay, because these patterns are going to be used for object oriented programming only. So here sample code will be there that will be either in C++ or Java. Then non-uses. So some example will be there for the pattern for already it is used for some of the application development. Those will be there. Those examples will be there in the non-uses. Then then last is related pattern. So it will have all the other pattern that are related to that pattern. So this is about the description of the design pattern. So here when you are going to use any of the design pattern, so all design patterns that there will be 13 sections will be there, and these 13 sections are common for all the 23 design pattern. Okay, all these 13 sections will be there for all the 23 design pattern. So this is the catalog of design pattern. So catalog of like we are having catalog for books, or we are going to buy any of the cake or something, we'll have the catalog, and from that we are going to decide which cake we want to buy. Similarly, there are catalog for design pattern. Based on our problem, we are going to choose the solution from this catalog. So this catalog, what information it will have? It will have name of the design pattern. Along with this, there will be brief introduction of the design pattern. Okay, So this catalog will have all the 23 design pattern along with the brief introduction of the design pattern. So based on this, in this one or two detail about 1 or 2 line description, you will decide which pattern you want to use for your problem, to solve your problem. First is abstract factory. So this abstract factory provides an interface for creating families of related or dependent object without specifying their concrete class. Okay, so this is the first pattern. Then adapter pattern. Adapter pattern, let us class work together that won't otherwise because incompatible interface. If those classes are incompatible and we want to make them to use together, so for that we use adapter pattern. So example of adapter pattern, like I am having some VGA port in my system. I am having some HDMI port. I don't have VGA port. So but my projector is supporting only VGA port. So okay. So in that, and I'm having a VGA connector. So what I will do, I will use one adapter. Okay, VGA to HDMI adapter in order to connect the projector to my system. Then bridge design pattern. So it will separate the abstraction from its implementation so that two can vary independently. Okay, so here design, it is going to separate from the product. Okay, so that you can change the product like background and background and foreground. Okay, so you can make the changes independently. Then builder pattern. Builder pattern separate the construction process from its representation so that construction process can create different representation. Construction process can create different representation. So this, why this name is builder because this builder only builders are using. So if you are going to buy the house, every house will have the rooms, kitchen and everything. But the way builder is going to build in the separate way. Okay. So those both are separate. So plus by the same construction, you can create the different representation. Then chain of responsibility. So this chain of responsibility avoid the coupling between the sender and receiver. Okay, here the sender is going to send the request to the receiver by giving more than one object a chance, more than one object a chance to handle a request. Chain of responsibility object and chain of receiving object pass the request among the chain until an object handle it. Okay, so this is the chain of responsibility. Okay, so here the sender and receivers are not tightly coupled, so they are here no coupling. So sender will send the request. There will be chain of receiver. Okay, so whichever receiver can respond on the request, that is going to respond. So it will go to one object, receiving object. If it will able to serve that request, it will serve. Otherwise, it will pass to the along the chain until some of the object is going to handle the request. Then we are having command design pattern. So command encapsulate request of an object which allow us to parameterize the client with a different request and support undoable operation. So here every request will be given go in the form of command, so it will allow to the undoable operation also. So it allows to do undoable operation. So any request is going to be sent from client to server, it will, or any request is going to be sent when we are doing typing or anything, that will be in the form of object. For that object is going to created. So if we want to perform undo, we can perform the undo. Then we are having composite pattern. So composite pattern combines the object into tree representation and tree representation to form the part whole hierarchy. So here in composite, the client is going to treat individual object and composite object uniformly. Okay, so here like composite design pattern example is you are going to create any web page. So you are going to create any web page. That's the example of composite design pattern. So it is a combination of many objects. There will be a first frame will be there. In frame you are having buttons, text box, okay, and you are having some radio button, check boxes, text. So all are this comes under composite design pattern. Then decorator. So decorator pattern attach the additional responsibility in the object dynamically. Okay, dynamically, and it is also provide a flexible alternative for subclassing for extending the functionalities. Like in it is you can add some functionality additional responsibility to your object dynamically. Your application is running and you want to see notepad. So sometime you will find there is a horizontal scroll bar. You don't want horizontal scroll bar, you need vertical scroll bar. So what you can do, you can remove that. Okay, you can remove the horizontal scroll bar and you can keep the vertical scroll bar. You can attach the vertical scroll bar. You can attach the border also. You can attach the border in the document or border or boundary to the document. These all are the example of decorator design pattern. Then facade. Facade provide an uniform interface for the set of interfaces in a subsystem. So facade defines higher level of interface to make the subsystem easier to use. So here there will be a one uniform interface is there. From that only all are going to be connected. Like if you go to any of the company, there will be reception. Okay, from reception there will be connectivity for, or first you need to go to reception. From reception you will be sent any particular department, because all are, that is the uniform interface for the company. First you have to go to reception and from that you will be sent to your location. Then factory method. So factory method defines an interface to create the object, but let the subclasses decide to instantiate. Factory method lets the class defer the instantiation to the subclass. So here factory method. So here we'll have a factory for the toy. Okay, factory for the toy, and that is the main class. And in that one department is making one machine is making some car, another is making some horse. Okay, and some other is making some aeroplane. Okay, so here there will be a class factory and there is a subclass car, aeroplane, and horse or animal. So those classes will decide what type of object has to be created. Then we'll have the design pattern flyweight. So use sharing to support large number of fine-grained objects efficiently. So if there are more number of objects are there, for that we can go for the flyweight design pattern. So flyweight design pattern mainly used in the document. So here each character you are going to type, that will be considered as a object. We'll have a document, and in that you are having some thousands of characters. It means there are thousands of objects. So handling these many objects are very difficult. So here we can use flyweight design pattern to solve this problem. Next is interpreter. So for a given language, define the representation of its grammar along with interpreter that use the representation to interpret the sentences in the language. Interpret the language. Okay. So here for support of the languages, different languages, we use interpreter so that it support different languages. Your software, for that we use interpreter. Then iterator provide the way to access individual element of an aggregation of object without exposing its underlying representation. Okay, so here we want to, if we want to access without object without knowing their internal structure, then we can go with the iterator design pattern. So here implementation detail will be hidden. Then mediator design pattern, it define an object that encapsulate how a set of objects interact. Okay. How a set of objects interact. So here the mediator, through mediator only, mediator it is going to decide how the set of objects are going to interact. Then memento design pattern. So this memento, what it will do, without violating encapsulation, capture and externalize an object internal state so that object can restored to this state later. Okay, so here like you will change the screen. Okay, you will change your some application is there, like you are having media player, you will change its some skin and all this thing, and after that you want to restore. Okay, for that we can go with the memento pattern. So it remember, okay, you can restore to the previous state. Next is observer design pattern. So it defines one-to-many dependency between objects so that if one object changes its state, it will specify the changes to all other objects and update automatically. So here, if there is if we'll make the change in one object, all other dependent object state also need to be changed. So like we can take the example of student database. Okay, student database. This will one object, and then fee detail and okay, and student database will be there, fee detail will be there, and again there we can say that exam result or any other things will be there. If you are going to make the changes in the father name, it is going to reflect in all other table also, fee tables and its exam table also, this result table also. So that is the observer pattern. So if we'll make the changes in one place, it will reflect to all others also. It will reflect to all other object also. Then prototype design pattern. it specifies the kind of object to create using prototypical instance and create a new object by copying this prototype. So if we want to create same type of uh, design, same similar type of application, okay, then we can go with the prototype design pattern. Prototype already there, prototype is there, same prototype can be used for many application. Then proxy, that provide the placeholder for another object to control the access to it. So if we want uh, nobody will have the direct access to the object, it should have the access to the proxy, so that we should not make any changes to the original object. In that case, we can use the proxy design pattern. Next is singleton design pattern. Singleton design pattern. This singleton design pattern ensures that there should be one object or a global point of access to that object. So if you want to make sure that only one object to be created for the class, a single object to be created should be created for a class, there we can go with the singleton design pattern. So like if you are having a banking application, in banking applications, after login, okay, there should you log in, you should go to next page, and login will be allowed only on a single computer. It will not allow multiple login with the same username and password. So there it is using singleton design pattern. It is using singleton, so that only one object is going to create. Only one object is going to create. Then state, this allow an object to change its behavior when internal state changes, and the object will appear to change its class. Okay. So whenever the object change its behavior, whenever its internal state will change, object also change its behavior. And strategy design pattern. So here it defines some family of algorithm and encapsulate every algorithm and make them interchangeable. And this strategy lets algorithm vary independently from the client that use it. So there are we can if we want to do same like for the example, I want to create one. There are different way to do the sorting. Okay, we are having different sorting algorithm. So here we can use those sorting algorithm, and all are going to be encapsulated in this. And based on requirement, we can use this. We want to keep different strategy, like strategy comes under like we are having different interfaces, like we want to keep keypad interface, or we want touch interface, like for in our mobile also we are having a different way to unlock our mobile. Okay, so we can use the fingerprint scanner, or we can go with the face unlock, or we can go with the password. So there are three strategies are there. So any one can be used. Okay, one can be used to unlock the mobile. Then template method. So it defines the skeleton of algorithm in an operation and defining some steps to the subclass. So here main algorithm will be given, and in that some steps that are left on the subclasses to fill that as per their requirement. Then visitor design pattern. So visitor design pattern represent the operation to be performed on the element of the object structure, and visitor lets you define a new operation without changing the class of the elements which it operates. if we want to add new functionality to the system without changing the classes, we can add a new functionality. So that can be done through design Vista design pattern. So these are the 23 design pattern, and these 23 design patterns, if we use this 23 design pattern, we can solve any of the software problem. Based on our problem only, we can choose any of the design pattern. So here, how those catalog is going to organize. So it will be organized based on purpose. So there are based on purpose, it is divided into three parts: creational design pattern, structural design pattern, and behavioral design pattern. So here, the creational design pattern is related to the creation of the object. Okay, if you want to solve any problem related to the creation of the object and class, then we can go with the creational design pattern. And then structural design pattern. Structural design patterns are related to the relationship between the structure and object. Okay, structure and object. So if you want to solve any problem related to the relationship between the classes and object, then you can go with the structural design pattern. And then behavioral design pattern. Behavioral design pattern is it is associated with the interaction between classes and object. So any problem you want to solve related to the interaction between classes and object, then you can go with the behavioral design pattern. And based on the scope, that is there are class design pattern and object design pattern. So class design pattern associated with the any problem is related to the classes. Okay, class creation and class creation and relationship between classes and interaction between the classes. Then we can go with the class design pattern. And object design pattern is related to the creation of object and relationship between object and interaction between the object. So these are the different creational design pattern: factory method, abstract factory method, builder, prototype, singleton. And structural design patterns are adapter. There are two types of adapter class and adapter object. Then we bridge, composite, decorator, facade, flyway, proxy. And in behavioral design pattern, interpreter, template method, chain of responsibility, command, iterator, mediator, memento, observer, state, strategy, and visitor. So 5 design pattern falls under creational design pattern, 7 design pattern falls under structural design pattern, and 11 falls under behavioral design pattern. How to select a design pattern? So first is consider how the design pattern solve the design problem. Okay, so how the design pattern is going to solve the design problem. First, that is the criteria. Then second is scan intent section. Scan the intent section. So you will go to all the design pattern. First you will here what you will do. First you will take the catalog, and catalog you will see how the design pattern is going to solve the problem. Then you will, after deciding 1 or 2 or 3 design pattern, you will scan their intent section. So intent section will give the purpose of the design pattern. Okay, so by that you will get more clarity. Then next, study how the pattern interrelate. So you will see their relations. Okay, how this are going to be interrelated. Study how the patterns are interrelated. Then study the pattern of like purpose. What are the similar problems solved by the pattern? Then examine a cause of redesign. So examine a cause of redesign. So examine a cause of redesign. So why you are going to redesign the solution. And next is consider what should be variable in your design and what are the things are going to vary will be is going to vary in your design. Based on that you can select the design pattern. So this is the relationship between the design pattern. This diagram shows the relationship between the design pattern. So how the design this diagram shows the relationship between the design pattern. Next is how to use a design pattern. So here first read the pattern once through once thorough for a overview. So you need to read the pattern once for overview. Then study the structure, participant and collaboration section. Okay, these sections are very important because structure section has the class diagram. In object oriented program is class diagram is the main solution. So that will give you the solution. And participant, you'll come to know what are the different classes you need to prepare. And by collaboration section, you will come to know how those classes are going to interact. How those classes are going to interact. Then look at the sample code section and to see a concrete example of pattern in action. So here already sample code is given. So here you will get the example how the actions are going to perform in the sample code. So that you can see the example and you can decide whether you have to choose that design pattern, and it will help you to design the code. So because the sample code is given in either in C++ or Java. Okay, so based on your requirement you can use that sample code to design the classes. Okay, to design the classes and interface. Then next is choose names for the pattern participant that are meaningful in the application context. So here, if you are going to see the pattern, there will be some generic name will be there. There will be some generic name for the classes and object. So here, what you need to do, you need to choose the participant classes or object names based on your application, because there is some generic name. There will be some generic name. Then define class, and you can define the class. Then define application specific names for the operation in the pattern. And here, what are the different operations you need to create that also there in the class diagram. So here also the operation you are going to use in the class. So for that also name should be given based on the operation. Application specific name should be given for the operation also, because in case of design pattern there will be a generic name. Then implement the operation to carry out the responsibility and collaboration in the pattern. So then after defining the operation, then carried out whatever the responsibilities are going to be carried out by the operation. Okay, and responsibilities are going to be carried out, or what are the collaboration has been done, that you need to implement. So here we'll go for the creational design pattern. So here creational design pattern, we are going to see some sample design patterns. So it deals with the object creation, as I told you, increase the system flexibility in terms of what, who, and how, and when the objects are created. Object is created. So it is classified into two types: class creational pattern. So it is related to the creation of the classes. Then object creational patterns. It is related to the creation of the objects. So there are 5 creational design pattern: abstract factory design pattern, builder pattern, factory method, prototype, and singleton pattern. So here we are going to see the singleton pattern. So here, what do you mean by singleton pattern? When we want to create exactly one object of a class and to provide the global point of access, then we can go for the singleton design pattern. Singleton design pattern. Okay, here exactly one object of class if we need to create, then we can go for the singleton design pattern. So here there is only one access point. There will be one global point of access to the application. So you can see this. This is the structure, singleton implementation. This is the instance singleton. This is a singleton constructor and get instance singleton. So in election, okay, presidency election, you can in election there will be from if you want to like it is related to election. If it is like online election, online election is online voting will be there through we can say the through some e-voting will be there through some software. So in that login is allowed only once. Login is only allowed in a once. Once you cast your vote, you are not allowed to log in. Your instance, once instance will created, after that you are not allowed to log in again. Then motivation is need to create exactly one user interface object. If we want to create only one user interface object, then we can go with the singleton design pattern. Need to create only one print spooler applicability. So singleton pattern can be used when there must be exactly one instance of a class and to provide a global point of access to it. Okay, when we need some only exactly one instance of the class and we want to provide global access, global access point from there only, then we can go with the singleton design pattern. And second is when a sole instance should be extensible by subclassing and client should be able to use the extended instance without modifying its code, then we can go with the singleton design pattern. Then a participant. So here consists of singleton class with following, it will have only singleton one class will be there, singleton class, and there are different members. Static data member will be there, a private constructor will be there, a static public method that returns a reference to the static data member. Collaboration, client access the singleton instance through the singleton class operation. Client is going to access only singleton instance through the singleton class operation. Next consequences, control access to the sole instance. Control access to the sole instance, only from single instance only access will be there. Reduced namespace, permits refinement of the operations and representations, permits a variable number of instances, and this is the implementation. So one singleton class is going to be created. There will be private static singleton instance. This private singleton constructor is there, and public static synchronized singleton get instance. This operation, if instance is null, instance new singleton return instance. If no instance is created for the singleton, then only instance will be created for the singleton. Then only one instance is going to be created for the singleton. Public void do operation here. What if any other operation you want to perform through that application, that it will come under do operation. So this is the implementation. By using this code, you can use this code if you want to uh, solve the problem where you need only single object for the class. Sample code. So design a small ATM printing application which can generate multiple types of statement of the transaction, mini statement, detailed statement, etc. However, the customer should be aware of the creation of this statement. Ensure the memory consumption is minimized. And these are real world problem word example. This is the client. Okay, so these are the statement type: factory, detailed statement, mini statement, statement factory. So here our is this client is allowed to use, and in one ATM machine at a time one card is going to work, and he from there only he can perform the operation. Only single instance is going to be created. Okay, so here a client, he wants statement. Okay, he can want the statement. So here he can get the detailed statement or mini statement, and this based on the user choice, the statement is going to be generated. Statement is going to be generated. So code for statement factory class. So here public class statement factory extend factory, public static statement factory unique instance, private statement factory, public static statement factory get unique instance. So these get unique instance, and if unique instance is equal to null, then unique instance new singleton new statement factory system dot out println creating a new statement factory instance return unique instance. Then public statement type create in statement string selection if selection dot equal ignore case detail statement return new detail statement, if else if singleton dot n equals ignore case mini statement return new mini statement, and throw illegal argument exception selection does not exist. So these are the sample code, okay, for the singleton pattern. Related patterns are the other related pattern like singletons are abstract factory. Actually, singleton pattern will create the single object, whereas abstract factory will create similar type of object. Then builder pattern, builder design pattern, and then prototype pattern. It can be implemented using the singleton pattern. It can be singleton pattern. Then abstract factory pattern. So abstract factory pattern provides an interface to create a family of related objects without explicitly specifying their concrete class. Without specifying the concrete class, it allows us to create the family of related object. So here you can see this abstract factory. These are the concrete factory. Okay. So here the client abstract factory, here it can be without interacting the knowing their concrete classes. Okay, without concrete classes, here those abstract factory are going to create the product. Okay, abstract products are going to be created, product A and product B. So this is the main solution. This class only the main solution. This is only called pattern. This is only called pattern. This only called pattern. Then this is the software, non-software example. So stamp part has to be created. So without knowing, client is going to create the part list. Okay, part list. So here from stamping equipment only, it will get the right door, left door, and hood. Hood of the number of the mall. And abstract factory pattern, other name is kit. And motivation, creating the interface component for the different look and feel. If you want to create any like any we can say that any of the window, okay, window so with different look and feel, then we can go with the abstract factory pattern. So here we are having widget factory. So create scroll bar, create window bar. So client want to create the window, so it can create the PM window or motif window. So if he's going to create the PM window, so he through this motif widget factory, sorry, PM widget factory, it is going to create the PM window and PM scroll bar. Okay, if we want to create motif window, from this motif widget factory is going to create the motif window and scroll bar. Then applicability of the abstract pattern, we should use abstract factory design pattern when the system needs to be independent to the products it works without created. The system should be configured to work with the multiple families of the product. A family of the product is designed to be used together, and this constant is need to be enforced. A library of product is to be provided, and only their interfaces are to be revealed, but not their implementation. If we want to keep the implementation hidden, then we can go with the abstract factory. The participants are there in abstract factory patterns are abstract factory that declares an interface of the operation that create abstract product, and concrete factory implements operation to create the concrete products. An abstract product declare an interface for the type of product object. Then product defines a product to be created by the corresponding concrete factory. It implements the abstract product interface. And next participant is client. Use the interfaces declared by the abstract factory and abstract product classes. The collaboration, here concrete factory class creates the product object having the particular implementation to create different products, and the client should use a different concrete factory. Abstract factory defers creation of the product object to its concrete factory subclass. So here abstract factory will leave the creation of the product on the subclass, concrete factory subclass. Then consequences. So there are different benefits and liabilities of the abstract factory patterns. It isolates concrete classes. It makes exchanging of product family easy. It creates consistency among product, and supporting new kind of product is difficult in case of abstract factory pattern. So this is the implementations. So there will be abstract class need to be created for the products. Okay. So here for product A1, product A2. So these are the implementation. This code can be used during the implementation. And this is the real world example. Real world example for the GUI builder. So GUI builder can be built, and there will be a different way it is going to be presented. Okay, there are different look will be there for GUI. So nowadays you are having your mobile phone, you will have different, you can change the GUI. If you change the GUI, you will see the look and feel are going to change. So based on the which GUI you are going to change, accordingly you will see the icons and text and fonts are going to be changed. This is the sample code. These are the sample code. related pattern. Abstract factory use classes are often implemented with the factory methods, but they can be also implemented using the prototype. So a concrete factory is often a singleton. So there are some other patterns are there, factory method pattern. Okay. So these are the builder pattern, prototype pattern. Okay, so these are the some other patterns. So thank you. So we are having structure and collaboration, structure pattern and collaboration pattern. So for that we require a lot of time. It's a complete subject for one semester. So I have given brief introduction of the design pattern. Thank you. So any queries? So thank you. Any query is there?